right, Go Math 8-6, and today we're talking still about equations. We're going to keep talking about equations for the rest of the year. So what I want to look at now is just piggybacking on what I did in 8-5, which looked at my overall equations. Let's give something along the line of 7x equals 28. 7 times some number equals 28. Well, I'm going to do the inverse operation, or the opposite. And 7 times some number, instead of multiplying by 7, I'm going to divide by 7. I get x equals 4. 7 times 4 equals 28? Yes, it does. Okay? Now, we've looked at these in the past at addition. We've now done subtraction. We've done multiplication. We've done division. So the only thing that we have left to talk about are positive and negatives and fractions. So let's take a look at what a fraction might look like in this type of environment. So I'm going to go ahead and just kind of ignore all of the extra wordiness here, right? We're going to talk about properties of equality a little bit later, but we really just want to focus right now on getting an answer. 2/3 n equals 1/4. Okay, so just like I did yesterday, when I'm talking about my my inverse operations, instead of multiplying, I'm going to divide, and instead of dividing, I'm going to multiply. So if I'm dividing by 2/3 n, multiplying n by 2/3, I'm going to divide by 2/3. All right, so now I have 1/4 divided by 2/3. And we know with division of fractions, we're going to skip all the way back to unit 2. I'm going to keep it. I'm going to change it, and I'm going to flip it. 1/4 times 3 over 2 equals 3 over 8. And I can go back and check my work. 2 times 3 equals, or 2/3 times 3/8 equals 1/4. If I wanted to show that, I would know simplify. Checked my work, and I know I'm correct, okay? So all we have to do, the same exact thing that we had discussed in the last 2 days, actually, with the inverse operations, is to do the opposite. So let's try one more. I'm going to flip forward here. And a biologist divides a water sample equally. So the biologist divides a water sample equally among 8 test tubes. So I know whatever I have, I'm going to divide it by 8. Each test tube contains 24.5 milliliters of water. Write and solve an equation, find the total volume of the water sample. So I start with how much is my total water sample? And I don't know that. So I have a number, let's call it V, right? That's going to be the variable that I use for volume, because I don't know what it is. V is then going to be divided equally into 8 test tubes. So you can see where my expressions and my equations can follow right along with a verbal story, right? So if I have V, the total volume divided into 8 test tubes, and each test tube is going to end up with, 24.5 milliliters. At this point, I do want to answer in the unit, but I don't really care that they're milliliters at this. I just need to solve for the numbers, right? The only way that it's going to factor in until the very end for my unit is if I'm converting units, and we're not doing that right now. Just like we talked about previously, instead of dividing by 8, V divided by 8, because every fraction is a division problem, I can multiply by 8. And so what I really end up with here is 24 5/10 times 8. 8 times 5 is 40. 8 times 4 is 32, plus 4 is 36. And 8 times 2 is 16, plus 3 is 19. Now, 1,960 seems a bit excessive for me, and I have to remember that I have a decimal here. So I have 1 digit to the right of a decimal in my problem, so I'm going to have 1 in my answer. My volume, or V, is going to be equal to 196. And I can go back in and I'll put milliliters as my answer there. 196 milliliters. And I can always go back, especially if I have my calculator. There's nothing that says you can't have a calculator unless I specifically tell you you may not use a calculator. Use it, right? But write out your work. All you need a calculator for now is to take 196 divided by 8 and see, does it give you 24 5/10? Yes, it does. So inverse operations, they apply to every single problem we're doing. Hopefully by now you've realized that the last 3 or 4 lessons are solved exactly the same way. We're using the same skill over and over and over and over again. And that's our goal. We don't want every day to be a new thing that we learn, and then we move on to tomorrow, and then we move on to tomorrow. We want to keep using the skills that we pick up. So inverse operations Just take your time, work through the problem, and apply what you know.